Welcome back, Calculus. We are going to continue with 7.2. I'm actually just going to call this U substitution, which, if you look in your notes, will be it's written later on. I'm only introducing this first page to you because some students will do anti-differentiation this way, and it's undoing the chain rule. So it's like the chain rule in reverse. So that's why when we look at this problem, we are, the first thing they do is they ask you, well, what is the derivative of this? Well, as you recall, this is the chain rule. That's just why I'm already talking about it, where the derivative of sine is cosine, and you leave 3x alone, and then you multiply by the derivative of the inside, which would be 3. So 3 times cosine of 3x. So the main premise is, if I were to ask you to do the antiderivative of 3 cosine of 3x dx, it's pretty clear since we already found the derivative, and we know that the antiderivative of the derivative will cancel out, and the answer is just sine of 3x. And I guess I should also put a plus c in here since we've practiced that before. The main thing is to recognize that this is a true statement because we've already practiced that the antiderivative of cosine is positive sine. And to think about, okay, well, the 3x stays the same, but why does this 3 go away? Well, remember in the chain rule, what happens is we would multiply by the derivative of the inside. Some people might think about, okay, well, divide by the derivative of the inside. And it does work. The 3 divided by 3 will give you a 1 right here. Or I'm going to move on. I'll actually show you the answer key and how he phrases it is what most books phrase it as, is that if the derivative of that piece is written in the integral, then it undoes it, so to speak. So if I were to look at the next one, again, and you can look at all this page, they're all chain rule problems where you would say, okay, well, it's e to the cosine is the derivative of e to the cosine, but then times the derivative of cosine is negative sine. So if I were to ask you, I'll change colors again, the integral of negative sine of x, e to the cosine of x, dx, you could probably look at that problem. I don't know how good you are at just looking and telling that the obvious answer is e to the cosine, because I think you'd have to think about how the derivative of cosine is negative sine, and then you could cancel that out by dividing by negative sine, and you probably need a plus c in there as well. So as I said, I want to show you the answer key on how he phrases it. So if you want to hit pause in the video, copy this down. I'm not going to explain the problems this way. I want to explain it slightly different. But it is done correctly, so I'm not mad about it. But what you should recognize is if we have an inverse chain rule, like we're undoing the chain rule, basically what it boils down to is the integral needs to look like the chain rule. Like this looks like the ending result of the chain rule. So basically what we're saying is if there's a derivative of something else inside of the problem, then you can probably do the antiderivative of that. And again, you might want to pause the video. So I'll show you the way he does it on the first couple of problems. Then I'm going to show you how I would do the problem. So what he recognized, this is actually pretty much the same problem as the first one, is that the derivative of 3x is 3, so you can go ahead and, I guess fix it to just be this answer. And I've had a few students do the problems this way. That's why I want to show you. It's just not how my brain works. So as you look at the next one, you can see that, I believe this is the same problem that you have worked on. Yeah, the cube root of x squared plus 5. So as you're looking at the answer key, you can see that the derivative of x squared plus 5 is 2x. And so you can manipulate the equation slightly different. let me show you how I would do the problem. So if you want to hit pause and write this down and try to figure out the problems this way, go for it. But let me show you how I would do it using a process called U substitution. So what I do is I look for an implied parenthesis somewhere in the problem. So in this problem, I think it's pretty clear that the implied parentheses would be 3x. So what I do is I let u equal that piece. And then what you do is you take the derivative of that. So du, that's what u is. And on the right side, we're going to take the derivative of that, which would be 3 dx. Now, I've tried to teach it so many different ways. What I find works the best for students is they solve for dx, and they solve for it by multiplying 1/3 over. So now when we go back to this problem, it's still the integral. I still have a 3 here. And then what I do is I replace my parentheses 3x with u, because that's what it equals. And I replace dx with what that equals, which is 1/3 du. And now what I can do is I can cancel out that 3 and the 1/3, and then all I have to think about is, okay, well, what is the antiderivative of cosine? It's sine, and just write a plus c in here. But if we started with x's, then we need to end with x's. So this answer would be sine of, I go back and I replace 3x in for u. Sine of 3x plus c. And in my experience, most students do the problem this way instead of the way the author intends. So again, I look for parentheses. There's an implied grouping symbol right here. So off to the side, I'm just letting u equal x squared plus 5. So then du will equal 2x dx. And in my experience, students need to solve for dx, so they divide that 2x over. So now when I go back to this problem, I leave the integral alone. I leave 2x alone. I replace x squared plus 5 with u. And at the same time, I'm also going to change this cube root to be the 1/3 power. And now I need to replace, I'm trying to color code the same way, replace this dx with a 1/2x du. And what you notice is this 2x and this 2x will cancel. Now it's pretty easy because all I have to do is add 1 to my exponent and multiply by the reciprocal of my new exponent. Don't forget about your plus c. But let me change colors one more time. If we started with x, we need to end with x. So 3/4 x squared plus 5 to the 4/3 power plus c. And as I go back to that answer key, it's exactly what he had. Okay, and maybe my work makes a little bit more sense than just being able to look at that and tell that there's a shortcut. I'm not here to make you do the problem my way, but my way does work, and you do have to understand U substitution at some point on the AP exam. So look for your parentheses. 2x plus 3, so then du is going to equal 2 dx. And again, you might want to solve for dx, so we're looking at 1/2 du. So in my problem, I can then rewrite the integral. I'm going to leave 2 alone. Now I have sine 2x plus 3 is equal to u, and dx is equal to 1/2 du. Notice that anytime you change things in terms of x's into u's, everything has to be in terms of u in order to simplify. So 1/2 of 2 will cancel. The integral of sine of u is negative cosine of u plus c. And as you go back to the final answer, negative cosine, replace u with what it equals, 2x plus 3 plus c. Now, if you look at the next example that I have, just kind of going in order, there's 2 sets of parentheses, but there's definitely a better strategy, and that better strategy is noticing that the derivative of the bottom will give me the top, which is sort of what the advice was to begin with. So the advice is good. So you want u to be the non-derivative. The derivative of u needs to equal something else. So I'm looking at the derivative of that would be 2x plus 2 dx. I haven't been writing the parentheses in here, but it is technically everything is, it's almost like factoring out a dx. That might be a better way of explaining that. So in my past experience, students need to see how to solve for dx. Kind of limited on color option. I'll go back to that color. So what I'm looking at is this is equal to the integral. Just leave that 2x plus 2 alone. Replace the x squared plus 2x with u. And then dx is equal to 1 over that quantity of 2x plus 2 du. So we can cancel. The integral of 1 over u is natural log of u. Make sure you put absolute value in there. Because you could have a negative value in there. Let me go back to black. So our best answer is natural log of x squared plus 2x plus c. At this point, I'm not even sure if I want to show you the answer key because I don't like the way he works it out. I don't know how obvious that this answer is to you guys. The more you practice, though, the more it makes sense. And I can work through these problems all day. Oh man, going back and forth kind of gives you a headache though. Yeah, as I continue on, now this one's kind of straightforward. If you let u equal 3x plus 2, then du will equal 3 dx. So I'm looking at 1/3 du is equal to dx. And the reason why that's useful is that as you look at the integral of cosine of u, replacing dx with that 1/3 du, it makes sense that your final answer will be 1/3 sine of u plus c, but then don't forget that u was actually equal to that 3x plus 2. There we go. I should be circling my answers as I go. Anyway, I'm not going to go back and change anything. But, because some people then get stuck if they do the old trick and they say, well, the derivative of x squared plus 2 is not 3x, and then they get stumped. Well, doing u substitution fixes that. Look for your grouping symbol. We're looking at x squared plus 2 is our group. So du will equal 2x dx. So dx is equal to 1 over 2x du. So what we're looking at is the integral. I like to leave 3x alone. I'll rewrite the square root as u to the 1/2 power, and then replace dx with 1 over 2x du. So now what happens is the x's do cancel, but it actually makes sense then as to why it's 3/2. The antiderivative of that would be adding 1 to your exponent and then multiply by the reciprocal, so 2/3. Well, that's kind of nice. It all canceled. Don't forget about plus c. So we're looking at x squared plus 2 to the 3/2 power plus c. So I'm close to the end of my 15 minutes. So what I'm going to do is have you try these last two on this page. And I'm going to jump over to the answer key. So you might want to hit pause. And if you don't get the right answer, write it down, write down what you have, and come to class with questions. I don't know how many of you would want to work through this problem this way. U substitution is your friend. So please, please, please use it. And I'll see you in the next video to explain U substitution a little bit more. So I'm ending this first video here.